I'm going to talk to you about MD-PhD training, but I'm really going to talk to you about this in the context of training physician scientists. And who or what are physician scientists? These are individuals who are trained as both physicians and investigators, and they serve in many different functions. They are mentors, they're investigators, they're teachers, inventors, etc. Some direct MD-PhD programs. And they spent most of their professional careers doing research and applying research, and many but not all see patients. I do not see patients. And many but not all do research that somehow is related to human biology and human disease. And they work mostly in academic medical centers, but they also work at research institutes such as the National Institute of Health, in industry, and in government. And there are many different ways in which you can become a physician scientist or a clinical investigator, meaning that you work on clinically important problems that are directly relevant for human disease. You are here as college students. Some of you have graduated from college and you want to end up here. And the easiest, most efficient way is to matriculate into an MD-PhD program, which provides a training that will enable you to reach your goals. In some cases, you are in doubt. You don't really know whether you want to commit the time that is involved in getting both degrees. You matriculate in medical school, and in some cases you decide you made a mistake. You would really want to have the research training that the MD-PhD program provides. You apply for transfer into the MD-PhD program and you graduate. And in other cases, you don't get the PhD, but after graduation from medical school, you get the research training, and sometimes also during medical school, you get the research training that is necessary for you in order to have a sustainable research career. Many will decide, no, they're really not interested in medicine. They want to do research. They apply to graduate school. And at that point, often due to the kind of research problems they are working on, they decide they made a mistake. And what do they do then? That's actually a more difficult question, because it is exceedingly difficult to transfer from a graduate school into an MD-PhD program. But it turns out that with a PhD but no MD, you can still do clinical research. You can work on clinically important problems. You can't put a stethoscope on a patient's chest and listen to the heart, but you can work on tissues from human beings where the interpretation and implications of the work you are doing really depends on knowing the clinical condition of the individuals who provided the tissues or whom you actually are studying as an intact or biological organism. So MD-PhDs, but I would say physician scientists in general, they blend clinical and medicine with the discovery of application of new knowledge, and they therefore work at the intersection between science and medicine. And the bigger this intersection between science and medicine is, I think on balance, the more successful the career. If your science life is over here and your medicine life is over here, it's hard to have the career. And it is due to the fact that what you already know, your advisors are telling you, they can't keep up with the literature in their field. And so if you have to keep up with the literature in two disparate fields, it just doubles the problem. So, however, if you, as you walk from the laboratory to the bedside, and you now can use the information that you have obtained in the laboratory, that you think about that in the context of the patients you are taking care of, and you come up with new ways to approach the clinical problem or vice versa, as you walk the other way, you realize that the particular clinical problem that the patients you are taking care of might actually have answer in studies in the laboratory. Then, of course, you are in a fantastic situation and you are able to have a wonderful career. But I would say it depends on the very astute choice of the kind of research you're doing and of the kind of clinical medicine that you're practicing. So how is this done? It turns out there are about 90 active MD-PhD programs that are affiliated with medical schools around the country. Normally, if you go in, you'll see there may be a higher number, but this is the number of programs where there has been a student at least one student matriculating regularly every year. 44 of these programs, are about 50%, are partially supported by training grants from the National Institutes of Health through the National Institute of General Medical Sciences. These are known as Medical Scientist Training Programs, or MSTPs. And you often may hear the word, this is an MSTP. Well, it's an MD-PhD program that just has distinguished itself by being able to get support from the federal government. And what that means is that every 5 years, a program director writes an application for continued financial support of the program. NIH checks out whether the quality of the training that is provided is sufficient to warrant the further investment of taxpayer dollars in the training. And if they find that the program indeed provides an outstanding training environment, then they're willing to continue to support the program. So I think you can get great training in any MD-PhD program, but by virtue of the requirements that NIH imposes, which basically involves creating of a real culture of physician scientist training, you're probably likely to benefit from being in an MSTP, but as I said, you can get great training in any MD-PhD program. And this is important. Most MD-PhD programs offer students financial support, which includes stipends and tuition waivers. And this is not because we have a lot of money available. This is because we want to be sure that you can pursue the careers that we train you for. Medical college debt, as you know, is way too high, and it actually puts constraints on the kind of careers that graduates can pursue after graduation. And if you want people to take the rather lengthy postgraduate training and fellowship support, we need to be sure that our graduates do not have excessive debt. And overall, I can say of any MD-PhD program, and there are the programs sort of take the medical school curriculum and the graduate school curriculum, and they mix the two curricula in different phases to ensure that you can complete the training in about 8 years, and that you graduate people whom you are willing to compare to the best of your medical school students and the best of your graduate students. And so the way the training is done is really a continuum. The first 1 to 2 years is mostly medical school focused. There's some graduate training activities just to make sure that you continue to think about biological problems with the mindset of a scientist. Then in the next 4 years or so, you do primarily research, you do some clinical activities, but research is hard work, it is mentally taxing, and we want to be sure that you focus on this, and therefore it's the amount of clinical work you do in different programs varies widely, to some extent dependent on the philosophy of the program leadership. And finally, you complete your clinical training. Some do graduate school research in the final training, although if you think about it, that's something you have to be very careful about, because you want to be sure that you get as great clinical training as possible before graduating. So what is important is here that each program is really unique. You've seen an MD-PhD program, you have seen an MD-PhD program. So what you find is that you really, if you want to pursue this career, you need to do a lot of homework in order to identify the program that is most suitable for you. All MD-PhD programs provide research training in what I would consider to be the traditional biomedical research disciplines. But biomedical research is changing rapidly, and there are a number of other choices that would sort of be considered very special just a few years ago, but now really begin to become mainstream, such as bioengineering and imaging, ethics. There are people who do it in the chemical and physical sciences, a lot in computational biology and bioinformatics, public health, social sciences. And there's a wide range of training modalities that are available to you, but what is important is that not every program offers every possible PhD. If you apply to programs that are geographically embedded in the home campus, you will have access to most of these disciplines. if you apply to programs that to a large extent are self-sustaining entity, in self-sustaining medical schools, such as, for example, the tri-institutional MD PhD program, we have the Cornell University is 250 miles to the northwest of us. So in terms of the daily management, could just as well be on Mars. We are focusing on more the traditional disciplines, but we have added in computational biology and bioinformatics and increasingly chemical biology into the training environment. But it's up, again, as I said before, it's up to you to find out whether the programs that you're interested in actually are being offered. So when you're in the program, what sort of say makes a program? There would often, but not always, be MD PhD specific courses. That's one of our expertise in the tri-institutional program. There might be visiting scholar seminaries, student and alumni presentations. There may be a student council. There will be retreats. These are key because these are the times when students from all years get together. There would be other social events, usually in combination with other activities in the program. Students go to national conferences and organizations, and we encourage students to go to these. And so the whole aim of these various activities is that we create a community that fosters excellence and a commitment to future career as physician scientists. So what's happening to people who graduate from the program? And so what you find is that about 90% of graduates pursue clinical residencies followed by research training. And the remaining 10, some decide to forgo clinical training and get postdoctoral research support, and a few pursue other kinds of careers. And the postgraduate training can be long. It is anywhere from 3 to 7+ years of training. And therefore, it depends on the specialty. It depends on what you yourself want to do. But what is important is to keep in mind is that, as I already said, the training takes about 8 years. And you have to look at a substantial postgraduate training afterward. So you're talking about getting into your first independent faculty position anywhere from 11, 12 to about 15 to 16 years after you matriculate into the MD PhD program. You're in there for the long run. I know this may not be a great recruitment ploy, but I want to be sure that everybody knows what they're getting themselves into. About 75% of the graduates become medical school faculty, and about 65% continue to do significant research, which is here defined as spending more than 50% of the time on doing research. These are actually very successful. About 3% of graduates from US medical schools have a dual degree candidates, but about 40% of all NIH grants to individuals who have an MD training, medical training, whether MD only or whether MD PhD, the MD PhD receives 40% of all the NIH grants. So that means they're extremely successful in terms of receiving grant support. But of course, that is what we have trained them to do. Many are found in academic leadership, and that will become increasingly important. We see more and more division chiefs, department chairs, and deans who have gone through the training in MD PhD programs, but they also go in and do other activities. Many MD PhD are founders of biotech, or they work in big pharma, they work in research institutions such as NIH and the Howard Hughes Medical Institute. So what I want to say here is, so when you look at this, when you look at the overall training, you can say we are really sort of training a large cadre of biomedical scientists that come in 3 different flavors. The MD graduates, they are quantitatively the greatest number, but of course not that many of them really have significant research careers. And they have research experience to be successful. They usually have done research during medical school, but in particularly they have had significant research training after they have done the fellowship training. They're PhD graduates who on balance, probably tend to explore more fundamental biological mechanisms. But as I said, if they work on problems, many of them work on problems that are of direct importance to human disease and do what you by any definition would call clinical research, The MD PhD graduates are sort of combine what I would consider to be the best of these two careers. They provide and the programs provide really a well-integrated training experience in which you have both a dissertation-based research training and you have clinical training. And the dissertation really plays an important role because that's when you really sit down and put together everything that you have learned and come up with a coherent description of the research you have been doing. You can be in the lab and you can sort of work, but it's really when you explain what it is that you've been doing, you try to put it together into a coherent picture, that's when you find out you really learned what it means to be a scientist. The research is hypothesis-driven, mechanism-focused, and it's not just an after-the-fact tabulation of outcomes of different clinical studies. And what is important when you look at the MD PhD training compared to the MD and the PhD is that it takes less time to complete an MD PhD than it would if you took an MD and a PhD. Average time to graduation from an MD PhD program is about 8 years nationally. The medical school is 4 years, and the average time to graduate from a graduate school, a PhD program, is on the wrong side of 6 years, meaning that people would take more than 10 years to complete the 2 degrees separately. So we save you between 2 and 3 years by having the combined degree program. And the reason that is possible is that the graduate training builds upon what the students learned in the first 2 years in medical school, and the final clinical training builds on what was learned both in the 2 first years and in the research years, where the key thing you learn as a scientist in the laboratory is how to solve problems. And you learn how to, sort of say, recover from your mistakes. You're not allowed to do mistakes in the clinic, but you learn how to predict what is likely to be a good path to approach a problem, what is likely to be not so good path, and that's the training you bring into your final clinical training. So sort of related to the same, what is special about MD PhD education and training? If you compare the MD PhD versus the MD, it's clearly the structured research training. You can get the research training as an MD without getting a PhD, but now you have to fend for yourself. As an MD PhD student, people have thought hard about what constitutes the best training. And if you compare the MD PhD versus a PhD, the key thing is the understanding of human biology. And in particularly, which is one of the really hallmarks of what comes through in a good medical school curriculum, how normal and abnormal function results from complex interactions at many levels of specialization. This is something I can talk about for a long time, but I'll spare you that. So one of the reasons you're sitting here is you want to know, how can I get into such a program? And it turns out that there are, sort of say, there's a rational way to approach this problem. So what are we looking for? What are the kind of people we see? We want people who have a passion, and this is an order of importance. Passion for research. That's by far the most important thing we are looking for. Concern for others. You're going to be doctors. And we want to have people who actually have good interhuman skills, and because that's what you have to have in order to be a good doc. We look for 2 other things, because both clinical medicine and research are done in teams. We are no longer in research having sort of the sole investigator working in his or her lab. So it's important to identify people who have an aptitude for working with others, and also, given the training we provide, we clearly are training the people who we expect to be the leaders of teams. Not everybody will want to do them, but we need to be sure that we select people who have the potential to lead these teams. And finally, we seek a diverse student body. And the reason we do so is that, as I said before, NIH, or the US taxpayer, invest a significant amount of money in training physician scientists. And this is not altruism. This is because the US taxpayer expects the beneficiaries of this training to go out and solve problems that are important in society. And in order to be sure that we actually address the problems that are important in society, We need a diverse student body who approaches the problems from many different points of view. So it is important, I think, in my opinion, it's important to have a group that is diverse in ethnic backgrounds, but it's also important to have a student body that is diverse in socioeconomic backgrounds in order to be sure that we train individuals who actually are going to work on the important problems. How do we evaluate our applicants? The first is, again, the quality of the research experience. But the academic records, GPA and MCATs, are clearly important, not because we believe that a GPA or an MCAT score actually is a predictive of how you will be in the laboratory, but because you have to complete medical school. And so it is important that we select individuals who basically are going to breeze through medical school and can focus on the research in the laboratories. We look at personal statements, and in particular why people want to become physician scientists. Letters of recommendation, but remember, not many people write poor letters of recommendation. So on balance, I would say this is not quite as important. But we want to see experience in caring for others. What we do not care about are that you have shadowed a physician. It's a passive experience, doesn't count. And it doesn't count in medical school admissions either, despite what you may hear. We want only active experiences count. So if you're on EMT, that's fine. But sort of just being shadowing the local cardiovascular surgeon doesn't count for anything. And then we look, of course, on extracurricular activities and life experience, where you have to remember that for an MD PhD applicant, your extracurricular activity is largely spent in the laboratory. If it isn't, we sort of ask exactly what is going on. So what we are therefore getting at is, so one of the questions that always come up is, what do we mean by substantive research experience? And it is sufficient research experience to understand what you are getting into. And you can sort of say satisfy that in many different ways. You can have multiple different summer projects, but we don't want sort of the scientific butterfly. We want somebody who has stamina and ability to focus. You can do a senior thesis research. You can do 1 or more years pursuing research activities after your undergraduate degree. So I would say this thing, just want to go back to this problem here. I think it's perfectly okay to spend 5 or 4 summers working in the same laboratory, or spend 4 summers working in 4 different laboratories. But when you write in your essays what it is, why you did what you were doing, you need to explain, so to say, why you made the decision to do it. In both cases, it has to be due to an active decision on your part that we can evaluate. So because that's how we basically are able to sort of make a guesstimate about how you will be as a student in our program. Overall, I think what we are sort of leading up to with all of this is that you are familiar with the idea of testing an hypothesis, which for everybody who has been doing science means that you are familiar with the fact of life, that many of your best ideas turn to dust. You know that you will fail more often than you will succeed, but you have the resilience and the stamina to go back, test why, go in to evaluate why did the experiment not work out the way you thought it should do, refine the experimental design, develop the new experimental methods, and go on in your research. So it's always good to have numbers. I'm a very data-driven individual. And so on September 1 last year, which is the last real hard number we have, there were 5,119 MD PhD trainees and 83,353 MD-only students in US medical schools. So you see that MD PhDs are relatively rare beasts, and you have to keep in mind that these individuals are in MD PhD training for twice as long as medical students are in medical school training. So you see it's really a small number that are MD PhD trainees. Of the 2013 entering class, 36% were women and 12% were students of diversity. This number turns out to be almost exactly the fraction of women or the percentage of women in the applicant pool. So women, when they apply, do just as well as men, and women, when they graduate, are on top of the class exactly in proportion to the representation. They do great. The number of matriculants who are students of diversity is clearly too low, but that is a problem that we still need to work on for many years. And what is important, I think, for anybody who thinks about this is that about a third of all MD-PhD applicants matriculated into an MD-PhD program. So that means that the number of applicants actually is relatively modest. It turns out it was 1937. And so this is the total applicant pool for the 2012-2013 admissions. The average MCATs were pretty good. The average GPA was quite respectable, but there are a large range. And when we look at the matriculants, you see it's a little less than a third, but pretty good. The average MCATs are much higher. The average GPA is much higher. And there's a range, again, of both MCAT scores and of GPAs. I personally think that 23 is too low for comfort in terms of how you will do in medical school, and 2.8 is probably also cause for concern. And so, but we take these individuals because there are other strong characteristics, and the programs decide that the upside potential beats the downside risk in the admissions process. If you look at sort of more the distributions, what you find is that this is sort of the range of MCAT scores, and this both tells you sort of where you need to be in order to have a good chance of getting accepted. But what I want to point out here is even if your MCAT and also in the next slide your GPA is sort of in the stratospheric range, you don't necessarily get in. In fact, we don't necessarily interview you. And why do you think that is? Yes, that's part of it, but also it's because you provide no evidence that you are really excited about science. You are not. I mean, you may be very good in a very structured environment, but you may not be that good in the more chaotic environment that exists in the research laboratory. And sometimes that's very clear. So this shows again when you look at the GPAs, the low GPAs, you don't have that great a chance. But even if you have 4, you don't necessarily get in, and it's for the same reason. So when you look at the applications, it turns out that you apply through the American Medical College Application Service. You do so the summer before your entry year. Each program will have secondary applications, and they vary from program to program. You don't see the secondary application before your AMCAS application has been verified, and then it is sent out to you. And so that's one thing you have to do. The other is letters of recommendation. And I just want here to say that you have to plan your letters of recommendation. The best strategy would be that you approach faculty in the spring of the summer where you're going to apply, so that they have plenty of time to write the letters, and you don't have to chase them down come August or September, where they're busy with the teaching that is coming up in the new semester. And you need to be, therefore, carefully selecting the faculty you want to have letters for you. For MD-PhD programs, it is not very useful to have a letter from somebody whom you only knew in class. You might have been the best in a class of 500, but it doesn't tell us about your problem-solving skills, which is what we are looking at. So you need to have letters from people who truly know you, who are able to evaluate your ability as a future scientist. There are interviews, and we interview from October through February, maybe even early March. Final decisions are made from November through March. It actually has to be done by March 15th. Each program has to have issued a number of acceptances that is equal to the number of places it expects to have in the incoming class. There are revisit days in March and April. The process is complete by April 30th, except for maybe small changes in the wait list. And programs begin anywhere from June through August. And this is not Chicago politics, but I think nevertheless, when you plan your MD PhD application, I would say apply early and often. And these are data that are from the tri-institutional program. We are one of the early birds. Last year, and I'll explain why. So last year we had 570 applications. But only 441 were complete by November 1, which is the date that we on websites and numerous places state is the day applications have to be complete. We interview 75 applicants, and we don't interview anymore. And we send out 45 acceptance letters, which yielded an incoming class of 18 students. Few things you should know about these numbers. One, last year our application deadline was October 15th. In part reflecting this gap here, this year we made the application deadline September 30th, and I may move it up to September 15th, because there is a delay between the time you press return on the AMCAS site and that AMCAS has verified the application and sent it to us. Last year it was about 8 weeks. And that meant that many people who submitted applications in early September, the applications hadn't been verified by the time we had to close. And we closed because we interviewed twice. We interviewed the last Thursday of October and the Thursday before Thanksgiving. We have 37, 38 students come every of these days. It is somewhat of a logistic challenge, but it is great for the applicants as well as for the current students, because the applicants see whom they're being compared to, and the current students see, check out that we actually now are considering applicants who have the same quality as they are. So it's sort of say really a high for both. And the fact that we interview only 75 applicants is really a problem, because there are probably about 300 applicants that by any measure at that particular time are equally likely to have successful careers as physician scientists. But we don't, so that means that about 75% of the really highly qualified applicants are not interviewed. They are rejected just based on their paper application. We don't interview more, because if I interviewed, I'm not going to increase the size of the incoming class, because each student is expensive. So if I interviewed 150, it would just mean that we had double as many students were spending time and money coming, and each student who came had only half the chance of getting accepted. So therefore, I decided we just have to make the cut there. And also because my faculty would be sick and tired of me if they had to interview this many people without having an increased chance of having students in the laboratory. Yes? We can probably wait. What do you say? Yes, so when you ask, I think we should wait and then you go to the mic so the questions will get on the tape. And so this is where we are, but I'm done in a moment. So finally, I think I'll sort of say, what should you be looking for in an MD PhD program? So you have interviewed various, no, there's one thing I forgot. So what this means is that you need to apply to, 5 years ago, probably said 10 programs, now I'll say closer, 12 to 15 programs, which are some are riches, safeties in between, just like you planned your college application. There's no difference. And you shouldn't take it as a vote of no confidence if a program tells you that you will not be invited for interview. It doesn't mean that they don't love you, but they loved somebody more the day they evaluated your application. And so it just means they made a mistake. And what you need to do when you plan your application strategy is to be sure that that not all the programs you apply to will make the same mistake. And that's why you need to apply to 12 to 15 programs in order to guard yourself against the fact that 3/4, and this is not just us, all the top programs, 3/4 of the qualified applicants will not be given an invitation for interview. So, but what should you be looking for in a program? You should look at the research environment, the research institute, the quality of the faculty, research support. You should look at the students. Are they students that you would like to be compared with? What are the very specific research programs and what is the overall institutional support for science? You look at the academic environment, which are really the curricular structure, both in the sciences and the clinical ones. You look at whether the program seems to be well integrated into the institution, into the medical school and the graduate school, and internally has a good structure. And you look at all the things that you would sort of say, look at if you were applying to a graduate student, organization, community involvement, which of course, in medical school and MD PhD programs means, say, free clinics and all the various activities that students can be involved in. At Weill Cornell in the tri-institutional program, MD PhD students are very involved in the free clinic. In fact, MD PhD students are the administrative leaders of the clinic and have been so for many years. They have been very involved in the human rights activities and international medicine. In fact, our international medicine curriculum was initially started by MD PhD students. And you also go out and you look at the achievements of the alumni. Are the alumni at the right institutions? Are the alumni of the quality that you would say, boy, I would like to reach that point in my career? Very, very important. Who do you go to for advice? So when you interview at a program and you talk to current students, you should ask, if you have a problem, whom do you go to? And if they don't immediately can tell you who it is, next. You don't, because that's a problem. It is difficult to go through 8 years of MD PhD training. You have to know that there are people who really would look out for you. You look at the location. The training lasts 7+ years. If you need to see mountains, don't come to New York. If wherever you want to have opera, Lincoln Center is just on the opposite side of Manhattan. You need to have a sense of belonging or a good fit. That's very much a personal decision, and each of you have different criteria for how you do that. But I think you need, basically, your gut feeling has to be, that's the right place for me. And finally, and I can't overemphasize this, you should look at the student body and you say, boy, there are a lot of people who are smarter than I am, because they are the ones who will pull you up. You don't want to be the smartest, because that means that the rest are probably going to pull you down. You want to be in an environment when there's a lot of upward pull. And finally, I'll just say it works. So this is Du Cheng. He was in this group here in 2010 when I was lecturing, and when I came back in 2012, he came up to me and said, you said what I needed to do in order to get into an MD PhD program. He is a graduate of Humboldt State University, which is not a research-intensive undergraduate institution. And I explained that you need to do science, and he took a time at Stanford to work in a laboratory. He applied to us, and he was accepted. So, and finally, if you want to have more information, there are really incredible resources at the AAMC, Association of American Medical College website. And thank you for your attention. Questions? Yes.
Hi. Okay, so my name is Mercedes Cornelius. I attend UCLA. I'm double majoring in biophysics and applied mathematics, pre-med. Okay, so first off, I came in the middle of the lecture, so you're to which university MD PhD program?
I'm at the Weill, Cornell, Rockefeller, Sloan-Kettering tri-institutional MD PhD program.
Is that in America?
Yeah,
okay.
In New York City.
Just making sure, because I heard Rockefeller, and I know that there's like a place in okay. All right, so my first question is this, right? So I'm a sophomore, and I feel like I don't know, I feel like I may be, because I feel like this may be kind of personal, so I'm not sure if anyone else may have the same question, but since I'm doing the physical sciences, And I'm kind of have to manipulate it in order for it to have computational use in the biomedical systems. So, and I'm still trying to figure that out right now, right? But I know for sure that whatever I do, I want it to be something that is math and physics related. I mean, that's physics related, so I can apply it to some sort of computational means in the body. So how do you think I would compare to other students who are coming in MD, PhD with like life sciences and probably like higher GPA in comparison to mine if I struggled a little bit when it came to the physics and the math major in comparison to somebody who did like life science MD, PhD?
I think we wouldn't, we love people who have undergraduate training in the physical sciences.
I mean,
and
yeah, but I
engineering.
mean, like, okay, like.
But I think that we would not, I think what it actually would be very important is the kind of courses that we're taking. So personally, I think that if people that say physical chemistry it's probably the hardest undergraduate course that one can take. And if people take physical chemistry, they don't need to have the same GPA as they took general chemistry.
But that's true, not true? And I'm not trying to say this because
no,
I wanted
we look at of course we look at the GPA, but it's not a major decider, but we look at the GPA, we look at what were the kind of courses that people took, and I always scan that when I look at the applications, because if a person may have A in all subjects, but it looks like it is not very challenging courses that were taken, or a person may have, say, 3.5 or something, 3.4, but have really taken very advanced courses, and where it sort of sometimes that was reflected in the grades, and we say, okay, fine. What it is important here, however, is and I mean, we have to be careful with the quantitative estimators of whatever we are thinking about. But there are two different measures we have available. We have the GPA and we have the MCAT score. And the MCAT score, MCAT I always call the great equalizer, because it actually serves to compare students against some standard background from, standard measure from any background, any undergraduate institution, any undergraduate major. And that therefore helps me and helps my colleagues in the admissions process, because we can say, okay, the GPA was not that great. There were difficult courses, but when we look at the MCAT, this person did fantastic. The research experience is great. We are not going to worry about the GPA. But if the GPA is not very good and the MCAT was not that astounding, then we will be more reserved, because then we think maybe we are getting the same information from the two measures. And at that point, it becomes more of an uphill battle.
Okay, thank you. That was very enlightening. And then my next question is, don't worry, it's only 3. All right, and then my next question is, what do you suggest that I do in order to get a better understanding of the kind of MD, PhD research that I would, that I should start looking into for when I start applying? Because right now I'm an undergraduate research at CNSI, and I'm basically,
Excuse me.
I'm sorry?
CNSI?
California Nanosystems Institute at UCLA. And so basically what I'm doing is I'm modeling peptides on a computer modeling system in order to manipulate the molecules in certain ways for it to be better, whatever, for the chemist's use. And I don't plan on doing that for the rest of my life, or when I go into my MD, PhD, which but that could be applicable. I'm more of looking for things that I can use computational physics, right, and applying it to the body of systems. And I was wondering, how would you suggest me looking for outlets to further develop it?
Quite frankly, I think you should continue to do what you're doing, but you should be sure you get courses in biology, so you know what biology is. You need to do just a modest amount of volunteering. You need to know that you don't faint when you see blood. That's actually important.
That I don't, I'm sorry?
Faint when you see blood.
Faint when I see blood. Oh, yeah. Okay.
You're embarking on a career in medicine. I think when a undergraduate research experience that is primarily in silico, I do vary, everybody would vary, whether you would have problems, say, with animal experiments. So I think it would be good to have at least one biology or research experience. It could even, but it doesn't need at that point to be a major experience, but I can tell you that it's very difficult if you have MD, PhD students who cannot work with mice.
With what?
Who cannot work with mice.
Oh, okay. Guten Tag.
No. Any other questions? Yeah.
So I have a question on the type of courses to get into the program. I've been out of school for 3 years now, but I'm in a lot of clinical research. I'm running clinical trials, a lot of bench to bedside work. But I think the struggle is for me is that since I have this experience with Stanford, that it's really hard to take courses at a university, well, one for cost and then the flexibility around my work schedule. So right now I'm taking biology and chemistry at community college. I haven't taken the MCAT yet, but I wanted to know, where you take your courses at, what is the weight on that?
I think it depends on what, a little bit, or more than a little bit, actually depends on what your GPA was in your undergraduate training. And the higher the GPA is, the less important it is where you took the courses. The lower the GPA, the more important it becomes.
And then
it's sort of common sense.
Right, and then so the GPA you said is one factor, but then also I have one manuscript in press and then another one that I'm working on. So
Yeah.
does that
So that's a complicated question, and you will probably get as many answers as there would be program directors in the room if you asked every program director. My personal view is that publications do not matter very much. And the reason is, and that's always a disappointment for those who have worked very hard to get them, but the reason is that the criteria for including people as authors on papers vary enormously among laboratories. So we don't know what it really means. A two-author publication with the applicant as a first author, that counts.
Yeah.
Yeah.
First off.
But anything else than that, and first author publications count quite a lot.
Okay.
Anything beyond a first author publication, being number third or fourth on the list,
Right.
is, in my opinion, of no use, because it doesn't help me make decision about how good or how not good you are.
Right. Okay. Thank you.
Any other questions? Okay, thank you very much for your attention.